Hello, Honors Algebra students. Mr. Lawrence here, and unfortunately I can't be there with you, but it's nice to have you hear my voice. Okay, I was going to say nice to see you, but I can't see you. That would be lying. I don't want to lie to you. So, anyway, I'm actually sitting while I make this video. All right, we are going to do something pretty easy today, frequency tables and histograms. I've got some examples in digits, and then you can work on the homework. So, I want to point out to you, first of all, before we get down to it, how many numbers are there from 1 to 10? Now, all of you, without even thinking, should be able to say 10, right? And if you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, there's 10 numbers there. But as soon as I change the question so the starting point's not 1, you all get bent out of shape and don't know. You give the wrong answers because you're not thinking. Okay, now let me ask you this. When I ask you how many numbers are there from 1 to 10, did you subtract, did you do 10 minus 1? Of course not. You didn't do that. So when I ask you to tell me how many numbers there are from 2 to 5, you shouldn't just subtract. You do 5 minus 2, you get 3, but if I count them, 2, 3, 4, 5, there's actually 4 numbers. So I've only told you this 85 times. I know if the virtual nerd says it, Nick's girlfriend, Nick will believe it, but if I say it, it doesn't even exist. But anyway, by the way, Nick, have you introduced Asim to her yet? Anyway, if I want to do the subtraction trick, 5 minus 2, I have to remember to add 1. Because I'm not counting the spaces between the numbers. That's what the subtraction trick does for you. I'm counting the actual numbers. So there are actually 4 numbers from 2 to 5. Okay, if I want to do it with a harder problem, like say how many numbers are there from 37 to 91? Well, I can subtract 91 minus 37. All right, and I believe that'll be 54, but then I have to add 1 to my answer. There are 55 numbers. And I'll leave that for you to verify, okay? I'm not going to list out all 55 numbers. All right, so this is going to be an important skill that we use when we make our frequency tables. So let me get here and hold on a sec, blank page, and let me bring up digits. Now it says, the numbers of home runs by batters in a local home run derby are listed below. What is the frequency table? What is a frequency table that represents the data? All right, so we're going to make a frequency table, and this should be really simple stuff. It should be reviewed, but if you don't remember it, this will be your chance to close a gap in your learning, and it's an easy gap to close. Okay. Well, the first thing I'm going to do, and I don't know if it'll let me write on here. If it'll let me write on here, I will be a happy camper. But if not, no, I didn't think so. All right, I'm going to have to go back. All right, I've listed those 7 numbers. So if you need to pause the video, excuse me, not those 7 numbers. I've listed those numbers down. If you need to list them out, you go right ahead, pause the video, get them down. You can back it up if you need to. I've got what? 7, 17, 14, 2, 7, 9, 5, 12, let's see here, 3, 10, 4, 12, 7, and 15. Okay, now many of you like to list them in order from least to greatest, and that's okay. With the frequency table, it's not really that important. First thing I'm going to do is I'm going to see what my lowest value is, and I think that's 2, and my highest value is 17. So how many numbers are there from 2 to 17? Well, 17 minus 2 would be 15, plus 1 would be 16 numbers. So I like that. From 2 to 17, there are 16 numbers. Okay? I like that because I can make 4 intervals, right? 4 intervals. 16 divided by 4 is 4. I like that idea. So my first interval is going to start with 2. Why? Because it's the lowest value. And then I'm going to extend it. I want 4 intervals, so I want each interval to have 4 numbers in it. So I'm going to add 3 to this. So I'm going to go from 2 to 5. That will be 4 numbers, 2, 3, 4, 5. My next interval then will go from 6 to, add 3 to it, 9. Yeah, if I add 3, I'm actually having 4 numbers. Think about it. 6 is the first one. I have to add 3 more to get 4. Yeah. So then I go from 10, just add 3, to 13. And then finally, from 14 to 17. And I like that. It's going to work out really well. So to make my frequency table, I'm going to count up how many fell between 2 and 5. So let's see here. There's 1, 2, 3, 4, 5. And often you'll see these presented as tally marks. 1, 2, 3, 4, and then 5. Okay, or you could see a 5 here. Then I'm going to count from 6 to 9. So I've got 1, 2, 3, 4. So it'll be 1, 2, 3, 4. All right. I feel like I made a silly mistake here. 2 to 5, there's 5, right? 1, 2, excuse me, 3, 4, 5. Yeah, the 1. Okay. Then 10 to 13 is going to be, let's see here, 10 to 13. I see 1, 2. I only see 2. And then 14 to 17, I see 3. So it's going to be 1, 2, and 3. So there's my frequency table for those numbers. Okay, that's it. That's a frequency table. Now sometimes they will ask you to do a frequency table with a certain interval. Like for example, the second problem here, and I'm not actually going to do it, but it says, what is a frequency table for the data below that uses intervals of 5? All right, well, intervals of 5, then I'm not going to start at, or I'm not going to go from 2 to 5. I might go from 0 to 5. I might go from 2 to 7 or something like that. So that's a frequency table. Now, the frequency table can be a great organizing tool helping us to make a histogram. All right, so let me get this problem up here. And so you see they gave us these numbers here. What are they? I've got to write them down. 7, 10, 1, 5, 14, 22, 6, 8, 0, and then 11, 13, 3, 4, 14, and 5. Okay, so they want to know the data are the number of hours per week a group of students spent watching television. What's a histogram to represent this data? So first thing I'm going to do to make my histogram is I'm going to start with a frequency table. So I've got the numbers here on paper. Hopefully you've written them down. Again, if you need to, pause the video and get them down. And I see that my lowest number is 0, and my highest number looks like it might be 22. Now, from 0 to 22, hold on, I'm going to sneeze. Cover your ears. Sorry about that. There's 23 numbers, right? 23 numbers. I don't like 23. I can't divide it evenly. So I'm going to go from 0 to 23, and then it'll be 24 numbers, okay? And so I'll go by intervals of 6. So I'm going to go from 0 to 5, right? I'm adding 5 each time, okay? And then from 6 to 11, and then from 12 to 17, and then finally 18 to 23. All right, so let me take a look at my data here, and hopefully again you have it written down. 0 to 5, I have 1, 2, 3, 4, 5, 6. Looks like I have 6. Instead of making tallies, I'm just going to put a 6 there. Yeah, that's okay to do that. All right, 6 to 11, I have 1, 2, 3, 4, 5. I have 5 there. All right. 12 to 17, I have 1, 2, 3. 12 to 17, I have 3. And then finally, 22, or 18 to 23, I have 1. Okay, so here's how I make my histogram. All right, pretty easy stuff. So let me get like this. And I want to make it a little bit longer than that. Okay, and I put my intervals along the x-axis, and I do my best to make them the same width. And so my first interval, I believe, was from 0 to 5. Is that right? Come on, did you take that? Let's see here. There we go. Sorry, having a little technical difficulty. All right, so from 0 to 5. So I'm going to do my best to break this up equally here. So that would be 0 to 5. And then 6 to 11 might be like that. And the next interval will be about that width. And then about that width. That's pretty close. If you have a ruler or a straight edge, you can make it a little bit better. It's kind of hard to measure. I'm thinking maybe pull that over and pull that there. Okay. So let's see here. Shorten that up. Right. Now in a histogram, my bars are going to touch each other. So I'm going to go 0 to 5 right in here. And then I'm going to go 6 to 11. And then 12 to 17. And finally 18 to 23. Now, let's see. The biggest number, well, let's see, it looks like it goes 6, 5, 3, 1. So I don't have to go too high. I can count by ones here. And so maybe I'll go 1 like that. And again, I'm trying to make them the same width. It might be off a little bit. If you're on graph paper, it'd be real easy. What do I got there? 4, 5, and then finally 6. All right, so when I do that, I'm going to label 1, 2, 3, 4, 5, and 6. Okay, the first interval had 6, so it's going to make a bar like this. It's going to come over from 6, and it's going to drop down to that little boundary right there. Okay, the next one had a 5, I believe, if I remember right. And see how they share the side of a bar? Yeah, the intervals share the side. Okay, I think I went 2 and then 1. Is that right? No, 3 and then 1. So then 3 is going to come over here. And, oop, that's off a little bit. So I can move it over. Problem solved. And then finally 1. And 1 would be like this. Okay? And this histogram tells me a lot. You see, a histogram can either be like very symmetrical or it can be skewed. If it's very symmetrical, it's going to look like either the highest or lowest points are in the middle, right? This one, however, looks more like this, like you're going downstairs. We would say that it's skewed to the left. If it was symmetrical, the rectangular bars would peak in the middle, and you would be able to drop off at the ends. So you might have something like this, and then there might be one like that, and it doesn't have to be perfect. And then it's going to start to drop off a little bit. Okay, and it can be off a little. It doesn't have to be perfectly symmetrical. All right, so we would consider this one to be symmetrical. And we know that the meaty part of it is right in the middle. The one I have here is skewed to the left because there are greater numbers over here to the left from 0 to 5 and 6 to 11. Most of my data falls. Okay, if it was skewed to the right, then we would have some little, oops, it would be in draw mode, sorry. We would have some smaller rectangles slowly, maybe quickly, getting larger as we move to the right. That would be skewed to the right. Okay, that's all you're doing. You're making frequency tables, histograms, and you're interpreting them. All right, my phone's ringing, so I better go answer it. Mr. Lawrence saying, have a good night, everybody.